Inside this factory, a completely different kind of electric motor is entering large-scale production. Here, thousands of individual operations are coordinated into one highly controlled manufacturing system. Unlike conventional radial flux motors, the electromagnetic flux in this machine travels parallel to the motor's axis. The architecture places a disc-shaped stator between two rotors, creating an exceptionally compact electric machine. The process begins with materials selected for conductivity, strength, thermal performance, and dimensional accuracy. Copper becomes one of the most important materials inside the machine. For this high-power density design, rectangular copper wire allows more conductor material to occupy the available space.
Every critical component can be tracked through the manufacturing system.
Before assembly begins, material quality is checked against strict production requirements. Piece by piece, the segmented structure becomes the heart of the motor. What began as individual conductors is now a complete electromagnetic structure. While the stator is being prepared, the rotor assemblies follow their own precision manufacturing path. Permanent magnets provide the rotating magnetic field that interacts with the stator. Each magnet must arrive at exactly the intended position and orientation. Before the rotor can meet the stator, its geometry is checked again. At high rotational speeds, even a small imbalance can matter. Electrical connections now turn the stator into a functional electromagnetic circuit. The finished rotor combines precision machining with carefully controlled magnetic components. Electrical insulation is tested before the motor moves toward final assembly. Protective processing helps stabilize the windings and manage the demanding electrical and thermal environment.
Controlled curing prepares the electrical assembly for its final mechanical integration.
Mercedes-Benz describes the production system as approximately 30,000 square meters across 3 halls and 7 production lines.
The copper must now be shaped into a complex geometry without damaging its insulation or reducing its cross-section.
Each bend has to land within extremely tight process limits. Automated cells transform the conductor into precisely shaped electrical windings. Consistency is critical. Every coil must occupy its intended position inside the stator. The stator is built from precisely manufactured segments, rather than a conventional continuous architecture. Laser technology is used within the production system to create and join components with high precision. Joining turns individual pieces into a mechanically stable electrical structure. Machine vision checks geometry before the next operation begins. Managing heat is just as important as generating power.
The housing provides the structural envelope for the completed drive unit.
Rotational components are installed using controlled force and measured positioning. The shaft becomes the mechanical link between electromagnetic force and rotational motion. The rotor assembly now becomes a single rotating mechanical system. Before the final assembly, rotational behavior is checked under controlled conditions. Digital production systems connect machines, measurements, and quality information across the factory.
Artificial intelligence also supports quality control. By analyzing production data and visual information,
each station adds another layer of precision until the separate systems are ready to become one motor. Now the most demanding moment begins. Mercedes-Benz calls this final joining operation the wedding. Powerful magnetic forces act on the components. As they come together, the challenge is not simply bringing the components together, it is keeping them precisely centered. Mercedes-Benz states that the stator must remain within the magnetic center plane, with a tolerance of less than 0.1 millimeters. In the final fraction of the process, an intelligent control algorithm makes the last positional correction. The central electromagnetic machine is now complete. Next, the motor core enters the structure that will protect and support it inside the vehicle. Every critical fastener is tightened according to a controlled sequence. Electrical interfaces are added to connect the motor with the vehicle's wider electric drive system. Thermal connections complete the path for managing heat during operation. In the high-performance electric drive unit, the motor is combined with a compact input planetary gearbox.
Sealing protects the precision assembly from the environment surrounding it.
Tiny differences in gear geometry become important when mechanical power is transmitted at high speed. The electric motor and gearbox now become one compact drive system. Final fastening locks the precision components into their production configuration. Electrical testing verifies that the assembled system behaves as designed. Controlled rotational testing confirms the mechanical system is ready for performance validation. The front axle axial flux motor is designed to reach rotational speeds above 15,000 revolutions per minute. Thermal behavior is measured because performance depends on controlling heat as well as producing power. Sealing systems are checked before the unit can leave the production line. From raw conductor and precision metal to a complete high-performance drive unit, the transformation is finished. What once demanded prototype-level precision has now been engineered for large-scale production. The remarkable part is not a single machine. It is the coordination of the entire system. Mercedes-Benz says the production system contains 98 process steps. "65 processes are new to Mercedes-Benz, while 35 are described by the company as new worldwide. After automated testing, human expertise provides another final layer of inspection. After testing, the finished drive unit receives its final visual preparation.
The completed unit receives its final digital production record.
Identification connects the physical component to its complete manufacturing history.
Automation handles repetition and precision, but people remain essential to the process.
This is the final result: a compact electric machine engineered for high-performance applications. The axial flux architecture creates a remarkably compact package. In the new Mercedes-AMG GT 4-door coupe, the technology makes its production vehicle debut. The motor is integrated with other drivetrain components into a compact, high-performance electric drive unit. The architecture can be deployed across multiple drive units within a high-performance electric vehicle. The journey from copper conductor to vehicle propulsion is completed in a chain of precision operations. What looks like a simple compact machine is the result of hundreds of decisions in materials, manufacturing, measurement, and control. Once all the measurements are complete, the machine is ready to do what it was designed to do. Behind this compact machine is a vast manufacturing system built around precision, automation, and repeatability. From raw materials to a precision electric drive, this is where the next generation of performance begins. Mercedes-Benz produces axial flux motors. Lasers weld hairpins with AI. Magnetic forces reach 9 kilonewtons here to less than 0.1 millimeters.